to Snark Chocolate, a show about ZK products, where we break them down with rich flavors and sweet insights. I'm Queenie, and I'll be co-hosting this episode together with Omer. Today, we're thrilled to be joined by Bobbin Threadbare, co-founder of Miden, the edge blockchain to scale public and private transactions. Bobby, it's great to have you on the show.
Great to be here. Thank you.
So first of all, congratulations on securing a 25 million funding round in such a tough market.
Thank you very much. It was a lot of work.
I know it must be. So first of all, would you like to introduce yourself and Maiden?
Yeah, definitely. So, hi everyone. I'm Bobbin. As Queenie mentioned, I'm one of the co-founders of the project. I think to tell a few words about myself. So, right before kind of this raise and transition into being co-founder of Miden, I was at Polygon. Was one of the co-founders of Polygon. I've joined Polygon roughly, I think, 3.5 years ago now, at the time when Polygon decided to make this big bet on ZK. I think you guys probably are aware, like Polygon kind of went very deeply and all in on ZK, and I worked, I joined as part of that push. Since then, Polygon worked on a number of like ZK products, Plonky 3, ZK EVM, to mention a few. And before that, I was actually at Facebook working on the Facebook's cryptocurrency, DM, Libra. It had different names at different times. And before that, I was working with the Ethereum Foundation, also in ZK-related subjects. I think I got into Web3 actually via ZK. I got interested in ZK first before I got interested in blockchains. And my time at from the start was trying to figure out how to make ZK technology more accessible to people. I think my first attempt was like building a open source start prover and then trying to figure out a ZK DSL to make like writing constraints for starts easier. And then I actually think I created one of the first ZK virtual machines. I think it was back in 2020, and that ZK virtual machine became the foundation for what Miden is now. And so Miden actually started out as just a virtual machine, which I was building kind of like shortly after joining Polygon. And over time, I kind of came up with this protocol, which is kind of more blockchain protocol. And the idea of Miden was that, how would you design a blockchain if you thought ZK was a kind of like a primitive that was available to you, was a performant and ready primitive to use. In some ways, I think about it as like, how would Satoshi design Bitcoin if he had access to ZK VMs, or how would Vitalik design Ethereum if he had access to ZK VMs at that time? And so, kind of Miden designed from this first principle, saying, okay, we want to build a blockchain around capabilities of ZK. And I think the term that we gave to this is the edge blockchain, and I can go into what it is shortly. But basically, that was kind of the idea. Kind of in my mind, this is a paradigm shift in how blockchains could be designed.
Cool. And I also remember, so Polygon Miden started as EVM compatible rollup, right? And now you actually pivoted to a custom ZK VM with no solidity anymore. So what trade-offs did the decision unlock?
Yeah, so I think there was like a fairly long exploration phase during which we kind of tried to figure out how exactly can we build like, I would say it took about a year, maybe even a bit more, to figure out like what the Miden protocol could look like. And at first the goals were, okay, let's try to make it compatible with Solidity, because obviously EVM compatibility was one of the main things that people try to do. And I think there were a couple of reasons why we ended up not doing that eventually. One of the reasons was that within Polygon there was other teams working. So like there was a Hermes team that was working on the KVM, and for example, it didn't make sense to have two teams working on the same kind of ZKVM approach. But I think maybe even a more fundamental reason was that I couldn't figure out how to make client-side proving work with EVM compatible kind of setup. And there are a couple of reasons for that. One of the reasons is that when I actually started working on Miden VM, I did not think client-side proving would be possible for just EVM instruction set. I think it's still slightly out of reach right now. I think people are saying we can prove EVM today, but you do require still a big server. Maybe a few years down the road, it's not going to be the case, and you would be able to do it on a smartphone or something like that. But even right now, it is not. Like when I started working Miden like 3.5 years ago, I actually couldn't imagine the progress would be so fast. So like for me, thinking about like, okay, can we actually make ZK work on client-side proving and EVM seemed out of reach, much more out of reach than it seems right now. I think the second aspect of this is the way Solidity is designed and the way like EVM is designed is very specific to kind of a given state model where smart contracts interact in specific ways. And making it work where you want to prove individual transactions is very, very difficult. I actually don't know if it is possible. And the reason for this is that, for example, you want to do an ERC20 transfer, right? Like if two people try to prove a state transition of ERC20 contract, eventually there will be a conflict between the two, right? Like, and so you can't really do like individual proofs and then have this be reconciled somehow by the network. You actually have to come up with a different state model, I would say, a different execution model. And that is, in my mind, the most fundamental model. By even right now, I don't think I would be able to go with the EVM kind of compatible approach, or at least, I don't see a way how to make it work with client-side proving. Because again, you need to prove individual transactions, and unless you have a very different state model, and we can go into like what differences need to be there. I like making it work with EVM and Solidity is like very, very tricky. And so kind of the natural choice was like, okay, what can we do? And so right now, the way we make it work is that, there's a separate Miden VM with its own instruction set, which is optimized for kind of this, I would say, client-side proving in many ways. So like to give concrete examples of why it is optimized for client-side proving is, or how it is optimized. A lot of current ZK VMs use what is called like a wide trace strategy, where the execution trace is, hundreds and sometimes thousands of columns long. And that translates into two things. First thing is it requires quite a bit of memory. So you would hear that the proofs sometimes require tens of gigabytes, sometimes even hundreds of gigabytes of RAM to prove. And obviously, this is not an option if you're running on a smartphone where you're limited by sometimes 2 gigabytes, sometimes 4 gigabytes of RAM. And then the other problem is the resulting proof sizes are large. So like, if you don't try to optimize for small proof sizes where you have this wide trace strategy and you don't try to like recurse to like compress it even further, your proofs end up in the order of like 1 to 2 megabytes in size. And this is also just too big for the client side. So with Miden, for example, we have very narrow trace, and most transactions, like on Miden, can be proven with like just less than 4 gigabytes of RAM, like simple transactions that people would want to do on a smartphone. And the proof sizes are still not small, but I would say probably acceptable, somewhere around like 80 kilobytes to 100 kilobytes in size. So an order of magnitude smaller than what you would get with like a wide trace strategy. And so like that was one of the kind of like things that we optimized around MyDNVM. I think the other like aspect like of what programming language to use, we do have a different instruction set, but we also didn't want to create a new programming language because I think it is difficult, and we can go into other things. But what we decided to do is compile Rust and execute Rust. So like you basically compile Rust and make it run on MyDNVM. And we have a pipeline I can go through into how that pipeline works. But we basically are trying to make Rust work as a programming language for smart contracts on Miden.
Got it. So Miden was born for native client-side proving.
Exactly.
Cool. Yeah. Then do you expect the developers attracted to Miden to differ in any significant way from the typical Web3 developers we see in the industry today?
I mean, I think it's a good question. What is a typical Web3 developer, to be honest? I think there will be some overlap with the Web3 developers because we are, working on blockchains. And I think some of the use cases that we are thinking about that would be a good fit for Miden are a good fit for kind of blockchains in general. But I do think there is a somewhat of a learning curve, right? If you're coming from Solidity, you will need to learn new things. So like I don't expect overlap to be like 100% or maybe even 50%.
Mm.
I think we actually with Miden trying to target like um, several classes of developers, I would say. So like if we're talking about developers that work with Solidity, I think there is probably a slice of those who are trying to work on use cases that are difficult to build on EVM. And some of those use cases could be privacy related, some of those use cases could be scalability related, and we can talk into how scalability plays into this whole thing as well. I think there is also a set of use cases in Web3 who are working with Rust-based smart contracts, like Solana is a good example, Near is another good example. So if you already working with Rust, there's still a learning curve, but maybe not as big of a learning curve in trying to work on Miden.
Mm.
And then I actually think there is a non-Web3 developers as well, who are like, there is a huge set of people who know Rust already, probably much bigger set than know Solidity. And if we can attract a slice of them who want to experiment or are interested in blockchain smart contract development, that could be another kind of target group for us to work with.
Cool. I'm looking forward to Miden onboarding, some new developers to the space.
Yeah, I think this is the
Yeah,
like
we
I
need
think
new blood.
we all want to grow the pie rather than try to redistribute it, right?
Yeah. At least not the copy and paste kind of,
Yeah,
builders. Yeah.
exactly.
So I think we've already discussed that Miden was born for client-side proving. So is this client-side proving the core meaning of the Edge blockchain, or are there any other meanings?
I think edge is basically another way to say client side. I think there's a bit more packed into the term, the way I think about it. But it is by far the most important part. And here, I think in my mind, there is two aspects to client side. There is one of the aspects is proving, where you execute the actual smart contracts or transactions on the client side. And a client could be like your wallet, so like your smartphone, your computer, or it could be an app running like in a server, for example, or in a set of servers that are have their own consensus, for example. In my mind, whatever is not by the network is client side. So like that's how I draw the distinction. Um, and so kind of running the programs, executing the logic is part of it. The other part of it is where does the state live as well, right? So I think people talk a lot about like computational complexity and where does the computation happen, but I don't hear people as frequently talking about like where does the state live. And so in my mind, in the edge blockchain, state is pushed to the client side as much as possible. So your wallet maintains the state of your account. The blockchain that only, ideally tracks commitments to that state. It doesn't need to track the full underlying state. Like, I think one of the things, and going back to describing like Ethereum or EVM model with ERC20, for example, every time, every asset that you own, every ERC20 asset that you own adds kind of like a state entry somewhere in the blockchain, right? There's like like you own USDC. There's a USDC contract that says how that keeps track of how much USDC you own. You own, some other token. There's another smart contract that keeps track, and so every token you own adds. I don't remember exactly, but I think it's like either 20 bytes or 24 bytes to the state. And so if you can imagine you own hundreds of assets, that's like 20 bytes times 100, that adds to the state. And ideally, you don't want to grow this way. I think you want to have like doesn't matter how much you own, your kind of like contributions to the state should stay constant. And that is what we try to achieve with edge blockchains, where you actually move storage as much as possible to the edge as well. And it's not always possible. You still want to have like shared storage, and this is another aspect, kind of like at least of Miden design, where you want to move as much to the edge as possible, but not more, because you can imagine a design that doesn't have any public shared state, and that could work, but it is, in my mind, not going to be as useful. You still want to have public shared state that people want to interact with, but ideally they could interact with that using from their private accounts and things like that. And so this combination of pushing computation to the edge, pushing state to the edge, but at the same time retaining ability to have public shared state I think that's how I think about the edge blockchain.
That's very cool. So, could you please maybe walk us through the tech stack a bit so that we can understand the full picture better?
Yes, definitely. So I would say if I were to start with the protocol itself, I think Miden is based on this what we call an actor model. Or I guess not only us, the actor model is a fairly well-known paradigm in like distributed systems. It's usually you have like independent state machines that communicate with each other by message passing, and those messages produce and consume asynchronously. And so I think one of the main innovations that we did with Miden is just like to take the actor model and apply it to blockchains, but also made state transition of every actor ZK provable. So basically, the way the protocol works is that you have accounts, which are actors, and then communicate with each other by exchanging messages, which are UTXO-based nodes. And so in this way, Miden is actually a combination of UTXO-based state model and account-based state model. And a single transaction on Miden is a state transition of one account. And this is very important. Basically, if you think about transactions on other chains, like you sometimes update more than one account, but on Miden, a transaction is always a state transition over one account. You can read states of many accounts, but you can change only one account at a time. But every transaction can consume zero or more nodes and produce zero or more nodes. So you can think about like this, if I want to send funds to you, for example, I would execute a transaction that updates the state of my account and creates a node. And then in a separate transaction, you would be able to consume the node and you would claim the funds that I've put into the node into your account. And to describe this, like this is very important. Like you think on Ethereum, for example, the way this would work is that I would kind of log the state of my and your account at the same time, and I would transfer, like in a single transaction, I would transfer, I would update, deduct like funds from my account and update the balance of your account, and that happens in a single transaction. And that makes it extremely difficult to do client-side proving for because I need to touch states of two accounts. On Miden, I just in a single transaction, I decrease the balance of my account, and then in a separate transaction, you increase the balance of your account. That separates the state transitions of two accounts. That makes them both independently provable. So I would say this is like, in a very, very brief description, the actor model. And so the idea here is that every transaction is run through Miden VM. There is a what we call a transaction kernel that enforces like invariants that we want to enforce on the blockchain side. I didn't create any new tokens. I obeyed the logic of a smart contract that was defined within my account and all of that stuff. And then, the proof gets generated, and I send the proof to the network, and the network then, aggregates this bunch of proofs, and the network then verifies the proofs and puts them into a single block. So the idea is that you will have a single proof per block, and that also simplifies kind of operations of the network because all the nodes downstream can just verify this proof to be sure that the block was executed, was kind of built correctly. And so you solve, in my mind, two problems here. Well, more than two, but like two main ones. The first one is network does not need to execute my individual transactions. So like if I've executed a proven transaction, the network doesn't need to execute this transaction and generate a proof for it either. And so for most transactions, there is actually like no need to execute by the network these transactions at all. And the second thing is like once you've built the block proof, you do need to aggregate the proofs, and this is like requires recursive proof verification. Nobody else needs to re-execute this for either transactions or actually aggregation at all. So like the verification, you could imagine like validators just verifying the proof without having to execute, and therefore running on fairly light hardware. But yeah, this is like in a nutshell the technical details. I'm happy to go into any one of those. There's much more I didn't cover, but like this is kind of at a high level description of how Miden works.
Yeah, interesting. It seems it has some like benefits or highlights from the systems like Zcash and like ZK rollups.
For sure. I think one thing I didn't mention, by the way, was that the state that kind of Miden chain is composed of is actually three separate elements. One is like there's a sparse Merkle tree of accounts, which is different from kind of like, let's say, Zcash based design. But then there is also a set of UTXOs that are kind of very similar in way to Zcash, although the inspiration there came from a different place, and I'll explain in a second where. And then the third part is, so this set of UTXOs just tracks all the nodes that were ever created. And then we also have a set of nullifiers that track the UTXOs that have been spent. And this is very similar to Zcash, at least conceptually, where you have nullifiers to indicate which nodes have been consumed, because you want to break the linkability. Like if I'm transferring something to you, I don't want the network to know that I'm interacting with your account, right? So like you do require these nullifiers where when you generate your proof, you will say, okay, I'm consuming some node out of the set of all the created nodes. I'm not going to tell you which node I'm creating, but here's a nullifier for this node. And because nullifier is deterministically computed, there is no way for you to produce a different nullifier for the same node. So if somebody else tries to consume the same node again, they will have to create the same nullifier, and then the network will be able to detect the double spend problem. So the nullifier part is inspired very much from Zcash. I would actually say that like this, like I've been inspired by a number of different things to when I was thinking about Miden. The kind of the account-based model was obviously inspired by Ethereum. Like accounts on Miden are very, very similar to Ethereum. There are differences. Like one of the differences that all accounts are smart contracts. There is no, so to say, EOA accounts. Everything is a smart contract. The nodes, interestingly enough, like I know they exist in Zcash and I know they exist in Bitcoin as UTXOs, but I actually got inspired by Fuel. I was reading the Fuel documentation, and the way they've done nodes was very interesting. And so like a lot of the inspiration for how nodes work on Miden were actually driven by the Fuel design. And then, as I mentioned, nullifiers work very close to how they conceptually how Zcash does them. Although again, the actual implementation is somewhat different because we use hashing and we don't use elliptic curve cryptography. It's all like Stark-based systems. And I would actually say, I mentioned I worked at Facebook, but like the asset model is somewhat inspired by the Move programming language, where you have like programmable assets and things like that. So like the way assets in Miden work is also different. Like as I mentioned, they are not recorded in smart contracts. You have native assets that you can issue, but then like how they flow from account, you actually store assets locally. So like instead of your assets being recorded like in different smart contracts across the state, your account has a Merkle tree of all the assets that your account owns. And in some ways, again, it's not exactly the same, but the inspiration came from how like Move deals with objects and different types. So I think there's like 4 or maybe even 5 different sources of inspiration for me to like combine them into Miden protocol. And obviously it keeps evolving. Like we, as new things come across, we try to incorporate them into Miden as well.
Cool. I guess it's super exciting to design a brand new infrastructure for, ZK friendly or privacy friendly applications.
Yeah, and we didn't touch on privacy aspect yet, but for me, like, yes, designing a new protocol is like super exciting. I mean, obviously it has its own challenges, right? You
Yeah.
have to like basically try to evaluate a lot of things that people have not thought about before, and it's scary sometimes because you don't know what the right thing is, and you maybe like go down one path and realize that it's probably not the right path, and then you have to backtrack and try something else. But it is exciting. Like for me, um, like for me, it's not as exciting, for example, to build another EVM chain. Like for me, it's exciting to try to push the boundaries of what we can do and like make how can we enable new use cases that are not possible with EVM, for example, or maybe difficult to do, or other protocols out there. I do think we're very, very early in crypto in general. Like I think with what we have right now, we still only scratching the surface of what is possible. And I do think that new capabilities are absolutely needed to kind of expand the pie of crypto, as I said in the beginning.
Exactly. We're also super early for ZK applications.
For
Yeah,
sure, for sure.
yeah. But by the way, why did you choose to bet on Starks?
I think there were 2 reasons. One is like a very personal path dependent one, and the other one is, I guess, more objective one. But personal path dependent one is that I'm not a cryptographer by like I'm a software engineer, And so when I learned about ZK proofs, for me, it became almost immediately clear that this is the technology that needs to will unlock full potential of blockchains. But at the same time, like I didn't have the required skills to basically evaluate everything. So I had to pick and be very strategic in which set of things I limit my exploration to. Otherwise, I would just end up boiling the ocean and spend 10 years trying to learn this stuff. So for me, I had to pick something. And for whatever reason, Starks felt easier for me to understand. I think elliptic curves were a bit more complicated. So it's kind of I thought about, okay, I need to pick something, and I picked Starks. I read Vitalik's blog posts, and this is the thing that at least on immediate inspection resonated the most to me and with me. I think the other aspect is I was trying to think, and this is maybe a bit more controversial. I was trying to think, if I were to learn this, what is likely to remain relevant for the longest period of time. And given how Starks are post-quantum secure and utilize less of cryptography and things like that, it seemed like, if I invest my time learning this, it's more likely to be around 15 years from now or something like that. Now, it's still, I don't think post-quantum or, quantum computers are still as big of a threat as sometimes we will make it to be. So I think elliptic curve cryptography is still fine, but I do think that Stark and hash-based systems do have longer longevity. And for me, that choosing that was kind of the easier approach. I also think, and this is one of the reasons why I think Starks kind of resonated with me even after the first, I would say, 6 months to a year working with them, is that um, one of the things I try to do is build a ZK virtual machine. One of the first things I try to do is build a ZK virtual machine. And it wasn't obvious to me how to do that in a circuit-based setting, like Growth 16, for example. But Starks naturally have this property where you have a very small circuit that gets repeated many, many times when you build an execution trace. And this reminded me of the VM setup, where you basically have a state of the VM that evolves. I think one thing that was missing for me personally into how to build a full kind of fully Turing complete ZK VM is how would you have memory that is efficient and things like that, which became obvious once I learned about permutation checks and how you would do multiset checks or later lookup checks and things like that. But even without that, it seemed like you could build a simplified but still fully functional VM just with Starks because of the way how the Starks describe the circuits. There's a small succinct circuit that describes a single state transition, and then you just apply it hundreds of millions of times or billions of times if you need to get kind of execution trace of something that looks like a machine computation. So those were the main reasons for Stark. As I mentioned, there was it resonated well with me because of, I think, at least the perceived simplicity from my standpoint. Also, the machine computation versus circuit computation seemed like the appropriate model for ZK virtual machines to me. And then, kind of perceived longevity was post-quantum secure and all of that stuff.
So yeah, so Stark is definitely a very brilliant stack. So I want to dive deeper into client-side proving. So how does that work in practice? Like latency, proof sizes, and hardware requirements?
Yeah. So it really depends on what you're trying to do and what you consider the client. So I would say right now we're still on the cusp of, I think, what is in some cases it is fine and possible. In some cases it is still slightly outside of our reach. So to give you a concrete example, right now a simple transaction on Miden, a simple transaction to verify or execute and prove on Miden VM, you can do it in 1 to 2 seconds on a laptop. But if you try to do it on a smartphone, that will take you somewhere around 20, 25 seconds. And we can optimize that. We haven't we're not, for example, yet using GPU, web GPU or things like that. So there is a way to optimize it. I think there are ways to make it even faster on smartphones where it will take just a couple hundred milliseconds. Those require changing how you do signatures. So I think in Miden transaction, for example, by far the biggest part of the transaction itself is verifying the signature. Everything else, if I were to give you kind of the breakdown of a transaction, Miden transaction right now takes about 90K cycles or something like that. And like 80K out of that is signature verification. Actually, close to 85 is signature verification. And all the like enforcing the blockchain specific semantics, like doing like, figuring out like if this creating a nullifier for the node, for example, or updating the account state, it's fairly straightforward compared to signature verification. So we could make it work on the smartphone right now very efficiently if we were to change signature verification to something like proving a hash preimage. Like you can use like non-standard signatures, like this is, you can use kind of knowledge of a hash preimage as a substitute for a signature scheme. And in that case, you could do a transaction on a smartphone in like a couple hundred milliseconds and it will work. But it also requires like, some things that I'm not yet comfortable to. Like we want to run Miden first, and we can talk about it like with our approach to go to market. But I want to run the system with training wheels, and that doesn't allow us to use training wheels, so to say. So we have to use the signature schemes right now. Actually, the default signature scheme on Miden is a Falcon signature scheme, which is like a post-quantum secure signature, which uses lattices. And although this is not the main reason why we chose it, the main reason why we chose it is actually it's 10 times more efficient to run in Miden VM than the ECDSA signature. With that setup, as I mentioned, like you can run it fairly like you can do client side proving pretty well on a laptop. Smartphone client side is still doesn't quite provide you with a great UX. I think there are ways to address it both in the short term and the long term. So in the long term, I do think we'll get the proving systems down. Like my thinking is like 3 to 5 years down the road, we can shrink this down to close to 1 second on the smartphone as well. In the short term, we have a couple of options. One of the options is just to do delegated proving, where you ask somebody more powerful than what you have to do proving for you. And there are different trust assumptions that you can put in there. For example, you could try to do delegated proving in an MPC type of way where the provers don't learn much about the underlying transaction. I'm not familiar with anybody doing this for Starks yet, but I know people are working on this. The other approach is kind of like to relax some of the trust assumptions. So you can give up privacy to the prover, but you don't give up like the spend authority. That could also work. You just ask somebody else to generate the full Stark proof for you. You sacrifice privacy to that prover. But you still, the network still doesn't need to know what exactly happened. So you kind of like maybe give up privacy to your wallet, but not anyone else, or to your wallet provider. That's a trade-off, not an ideal trade-off, but you can do it like if you're running on a low-power smartphone, for example, and you don't want to wait 25 seconds, for example, for proof generation. The other aspect we're not quite there yet, but like we're exploring is that where even with Starks, you can offload some things to the delegated prover, but not everything. So for example, and this really depends on like being able to do recursive proof verification very efficiently, which we're working on. But you could say, okay, I'm going to offload signature like verification to somebody else, and they would learn that the type of a signature, but they would not know anything else about the account. They would not know the balance. They would not know who I'm interacting with. They're just doing the proof of the signature for me, and then I will just recursively verify the proof of the signature inside a smartphone. So it's kind of like in between giving up full privacy, but kind of giving up entire proof computation. So you're kind of like in the middle between, you still do some proving on the client side, but you try to delegate the most expensive parts to someone else without giving up too much privacy. So there is all these trade-offs in the short term, as I mentioned. I think in the longer run, as I mentioned, it's probably going to be mostly done on the client side because the proving systems will improve, and we'll probably also be able to do kind of delegated proving without sacrificing privacy as well. So that's, in the short term, there are some trade-offs that we need to make, I think.
I see. So will you build this delegation feature yourself, or you will work with other teams or outsource it to other projects, for example, like pharma?
I think we're talking with a number of different projects that I would love to. Like, I don't want to build everything ourselves. I think the simple proof delegation we can build ourselves, although like where basically the set where somebody else generates a proof for you, it is the same proof. You give up privacy to this. Something more sophisticated like NPC-based things, I don't think we necessarily have the expertise of want to do. So like project like Lagrange or Fermat would be very interesting in that context.
I wanted to follow up and extend the context here because building a new protocol is a huge undertaking. We already established that. So you do need to get some help. And I guess another question here is also you can just spend forever just like shipping features and like keep building. So how do you determine kind of like where to put the milestones, where to um, release some testnet to get some feedback and so on? And again, like the first question is, in which areas do you prefer to get help or build on work done by others?
Yeah, I think this is a great question because for sure this is a extremely huge undertaking, and you need to take like trade-offs in different places. So, first I would like to explain like how we approach like this deployment and where we decided to sacrifice the short term versus the long term. So, one of the things what we're doing, for example, is Miden is going to launch as a centralized L2. So the things that we don't want to solve in the beginning, which we will solve over time, are things like consensus or P2P networking. So we don't need to worry kind of building about the fully distributed system. We focus on kind of the basic blockchain semantics, that how people write smart contracts and user-facing features. And the idea is that we'll go to the mainnet with a centralized L2, and then we'll spend the next 2-3 years on decentralizing and making it a fully decentralized protocol where there's different block producers. I think this is important for a number of reasons, I would say. So one of them is like this time to market, where we don't need to worry about the consensus, P2P networking, and a bunch of other things that if you're building a full blockchain, you do need to worry about, and that could take like several years. I think the other aspect of this is kind of confidence in the underlying proving system, right? In a system where you do client-side proving, especially if there's a privacy aspect to it, which Miden does have, a soundness bug could be catastrophic, right? Like you wouldn't be able to detect it, you won't be able to recover from it until it's too late. And so our approach to this is to, again, because we're starting out as a centralized L2, we can double check the proofs that come in. And so like in the beginning, users get privacy against each other. They don't get privacy against the centralized operator. And again, this gives us time to harden the proving system. And as we decentralize, we can kind of slowly remove these training wheels and say, now there's like a higher level of privacy, and now is even more, higher level of privacy. And then maybe it will take us 3 years to get there, but we will enable the full privacy. So we kind of like split up the milestones in a way. We're going to have a relatively simple centralized system where we're not too concerned about like having we still will do audits and all of that stuff, but like it's not such a critical thing if there is a soundness issue in a proving system, because it's going to be double checked. Like obviously we don't want to have those, but it's not going to lead to a catastrophic bug, and so we can improve on the proving system as time goes on. I think in terms of where we want to get help is we've tried to keep Miden core team fairly small. Like Miden right now is like 17 people, and over the last as I mentioned, like I started building Miden maybe 3 years ago or so, 2.5, 3 years ago. And for a long time, it was just basically a handful of people. Like my team was like 5 people for the first year, and then we increased it maybe to like 10 people, and now it's like at 17. And so we work on a kind of a core aspects, but we are very like open to working with other. We actually work with people like from Lambda class and others who work on very core protocol related aspects, but we also work with like Ray Labs, Massa Labs, and a few others where, let's say, we have a DSL for Starks, and they're working on like to express Stark constraint. Massa Labs, for example, are helping us with the working on the DSL for we call it AirScript. If we need hardware acceleration, we can reach out and like to people who help us with hardware acceleration, both like let's say CUDA based or even like web GPU based and things like that. So we've been pretty flexible in like engaging with other projects and groups out there that could help us. Like if you mentioned delegated proving, we're happy to engage with somebody to help us with delegated proving. I think we think about this like the things that we try to do ourselves is the kind of core logic of the VM plus the core logic of the protocol. And for now, we're also working on like the node itself, but that could be kind of like something that others help us with. So I really try to make it so that Miden is kind of like a small team with a lot of friends who are building this protocol.
Are you also friends with Polygon ecosystem? Because you spent like the early
Yeah,
years
yeah.
being part of this ecosystem. Are you guys using, collaborating, have plans to integrate and so on with
Yeah,
the
yeah,
rest of
definitely.
Polygon?
So like for with Polygon, I think first of all it was like an amazing experience, like being incubated within Polygon. Like as you know, some of the brightest people in ZK space, especially, work at Polygon. So being a part of that team and that environment was very helpful. I think in terms of like technical aspects of it. We are, for example, right now we're still using the proving system that I built a while back when I was at Facebook called Winterfell, but we will probably move to Plonky 3 as it's very likely we'll do it this summer even, moving to Plonky 3 as an underlying proving system. It makes sense for a variety of reasons to do that. And I think the other aspect of kind of collaboration with Polygon is that, you said, you asked where do we kind of like take the trade-offs? Like, for example, we will integrate with the UG layer. So like becoming an L2 will be done through UG layer. We will be like what is called a native UG layer chain. And this is how we will settle to Ethereum. The other aspect of collaboration with Polygon is just like Polygon is a great BD machine, right? Like being able to like work together and understand like, especially on the institutional front, this is one of the things we didn't talk about like use cases for Miden, but I think one of the next unlocks is like working with the institutions out there to get them into Web3. And one of the reasons why institutions are very hesitant to come to Web3 right now is lack of privacy. Like I've talked to a bunch of different like traditional financial projects and companies, and they just can't do much on chain without some form of privacy. And so this is, I think, where the next unlock could come in and like working with Polygon on that front, because Polygon is very, very kind of one of the more institutional oriented projects, I would say, or has a lot of history and expertise in that area. So that is something that's absolutely very useful for us.
Speaking of use cases, are there any other use cases that you are targeting already that you guys want to kind of like support or engage with BD-wise?
Yeah, I think there are a few use cases that we think could be useful in right now. And this, I view this as like almost like a funnel of sorts, a reverse funnel, where you start with something very narrow and then you try to expand from there. So like the narrow use cases that we're exploring a couple, but one of them I think is what is really useful is like treasury management and OTC trading. I think for foundations, treasuries, VCs, whales, having their funds fully transparently like on chain creates a number of issues. One of the issues is full transparency like is not like in my mind always a desirable quality. Like no public company otherwise operates where everybody sees like every time you try to move your funds or pay your contractor or whatever. Like I don't think this is a like the desirable state of the world. And so these foundations have real problems. Like every time they sell something, like even to pay a contractor or whatever, like there is a they're broadcasting this to the world, which has sometimes very negative consequences. And so being able to do it in a private setting, I think this is helpful. It also adds security. Like I don't know if you think of a couple of months back was to Bybit hack, like a lot of funds were stolen. I think in a system where your your state lives on the client side, you're at the edge, like hacking, like first of all, finding out which account has $1 billion is like is not a trivial thing. But even if you find out, and you still need to get the state of that account, you still need to be able to execute a transaction against that state and all of that. So it becomes categorically more difficult. So you kind of get privacy and security and higher level of security than what you can get on a transparent chain or traditional chain. And so I think that one of the use cases of this, like basically treasury management, and OTC trading. And then from there, you can expand into more institutional use cases. I think institutional use cases are important, but it will also take some time to get there. Like, they operate on slower time frames than Web3. So like it takes, quite a long sales cycle, to use the standard enterprise sales term, to bring institutions and work with them. And for valid reasons, they need to get comfortable, need to make sure they, if they're going to put a lot of funds, it's and there's like processes and regulations and all of that associated with that. And then, expanding from that, there's like, I do think we should get to at some point to the original vision of crypto, of like being able to do cash-like transactions and payments. I think with stable coins, we're kind of getting there, but I also think you do need privacy for those as well. Like, I don't know how many people like use Venmo, and like, I don't know, Venmo is like in the US an app where you can make your transactions public or private. And I don't think anybody would like to have option where there is like no privacy and everybody can see who you're paying for what and all of that stuff. So if we imagine a state of the world where people do most of their activities, financial activities, and otherwise on chain, they get paid on chain, they save on chain, they invest on chain, they pay their grocers and their whoever on chain. I think that state of the world absolutely requires privacy, and I think that's the use case we would like to get to as well, but it's a bit further down the road.
So, Bobby, I'm still curious about how privacy actually works on Miden. So, for example, how can builders choose between maybe public, shielded, and fully private transactions?
Yeah, let me dive into this. So on Miden, the way we've designed it is like I explained in the beginning. There are accounts and there are nodes. And right now, when you deploy an account or when you create a node, you have a couple of options. So like you can have a public account or you can have a private account. And one of the separate kind of distinction between Miden and some other privacy-focused projects out there, for example, is that we don't mix private and public state in this way. So you can have an account that has both public and private state. You either have a public account or you have a private account. And so, and then when you create a node, you can also have a private node or you can have a public node. So like you can think about it this way. In the future, we'll also have encrypted nodes as well. But for now, let's just think of these two categories. And so public account, all the data lives fully on chain. So like you have the state of the account, the storage, the assets that the account owns, the code of the account, it lives fully on chain. For a private account, the only thing that goes on chain is the hash of the account. So like everything else lives on the client side. And then it's up to the user to decide, like, do I keep the state on my device? Do I put it? Do I back it up in the centralized service? Do I put it into decentralized, some kind of DA layer and things like that? And there are different trade-offs of like different approaches to managing your local state. But the idea is that your state lives on a client side, and the only thing that goes on chain is the hash. With the nodes, it's very similar. If it's a public node, then everything that is part of the node, and it's usually like there's some data associated with the node, there's a code associated, spend scripts associated with the node, as well as the assets that the node carries, that all lives on chain. With a private node, the only thing that goes on chain is the hash of the node, plus some metadata that we've added to simplify like routing of nodes and figuring out who is the final recipient and all of that stuff. And so I could have a situation where, I have a private account, like this could be my wallet, where everything is local to this account. And then there's a public account, for example, in AMM, where people want to do trading. And so I can create a public node, emit from my account that will go and trade with AMM, and then another node will be created that I can consume separately. If I create a public node, the network will know what I'm doing. I can also create a private node, or I can encode a kind of information that is being exchanged as private nodes. And in that case, the network doesn't know what's being computed, so or what is being carried in the node. And so we get privacy kind of in these boundaries of interaction between accounts. So like you and I can have a private accounts, and then you and I can exchange private nodes, and then the network doesn't necessarily know anything about what we're doing. And because we prove our transactions locally, obviously the code of the accounts is also local and all of that stuff. And then there could be like a public AMM that is fully known to the network and all of that stuff, and I can send nodes, and you can send nodes to it and interact with it. I'm using AMM as an example here. There are obviously many other smart contracts that can exist. But in that case, like the network will create transactions, the network will execute them, and that's why the state of those accounts needs to be public for public AMMs and others. And so I don't know, like let me know if that makes sense or if there's like you would like to go deeper on some of these things.
Yeah, so then I'm curious. So the users will also have public and the private addresses?
That would be an option, yes. Like if you create a public account, so like there is no notion of an address in Miden, to be honest. Like there is no like you kind of you can create an account has an ID, but you don't have to, like if it's a private account, you don't have to reveal it to the public, because I think one of the things is like because an account is a smart contract, you can put any kind of logic into it. So there is no tie to a specific signature scheme. So I could create like an account that uses Falcon signature scheme, or I can create an account that uses ECDSA as a signature scheme. Or in the future something else. And so the address is what I broadcast to the world, that I can have many addresses for the same account, for example, or I can have one. So like, and maybe I should explain how it actually works. So like the way it would work is that when I give you a note or I send you a note, I would put a script in the node that would have like a spend condition that you would need to execute to be able to consume the node. And in the spend condition, I can put an arbitrary program. So like the simplest program I could use is like your account ID. I could say like only your account is able to consume this node, and I would actually put in the script of the node saying, check if this account is consuming the node, and if not, then like panic or create an error. But I don't have to use an account ID. I could say like anybody who can prove that they know a signature against this public key for this message can consume the node, and then you could actually say, okay, this signature, this public key is associated with my account, and therefore I can consume the node. It could actually be like an arbitrary condition as well. I could say like I don't care who's going to consume the node as long as like some effects are going to take place. So like I could send you a node that says you can take it as long as you send me something in return, and that becomes like an atomic swap where I don't even know who's going to be consuming it. If I send it to you, you can consume it. If I send it to someone else will be able to consume it. So there is no need to make anything like an address public or anything. Like it could stay fully hidden. I mean, the network knows like the account ID of the given account, but the account ID is not something that necessarily has to be used for transaction purposes.
Got it. Then how does Miden navigate regulatory and compliance requirements?
Yeah. So one of the things that I didn't mention is like in our why we chose the centralized L2 strategy is kind of like thinking about this from a regulatory standpoint, right? So like for us, in a period while we operate a centralized L2 that kind of is double checking everybody's transactions, we actually know the state of the network, right? And so the users, as I mentioned, are private against each other, but not against the operator. And so from the regulatory standpoint, we're not that different from another L2 that is able to track the state of the network. And so I think during this period, like because people know that we can see everybody's funds, the probability that somebody is going to use Miden for illicit activities is very, very low. And even if they are, we would be able to like track them and figure things out. Now, this gives us again like a buffer of time to figure out how we can approach it and how we can build a protocol in a regulatorily kind of acceptable manner. And for me, there are multiple facets to it. Like I do want to figure out if there is a way to build a protocol which is what we call a threat resistant, where it's not easy to launder funds through it, but at the same time keeping so that people still have privacy. And I think there's some of this is still open research, to be honest. Like how do you add threat resistance where people don't have to reveal their accounts like information. And there are like some interesting ideas, like you can tie it to identity, for example. But there are open questions there, like how exactly do you define the identity? But like, for example, if you can specify like Sybil resistant identities, then you would be able to say, okay, you limit or throttle or impose some conditions. So like, if I'm transferring $10,000, like I don't need to make it public, or I have no like restrictions. But if I'm trying to transfer 10 million, then maybe there's like time delays that need to happen where somebody can, I can't transfer them as quickly, or I need to meet some other conditions before I can do it. This only works again if there is like a Sybil registered identity system built in, which is a big open question of how to make it work. But there is like, so our philosophy is that we will, as after we go to mainnet, we will kind of spend time and effort and trying to think like what are the ways to make this work within a regulatory compliant way. And the answer could be like some combination of like tech aspects, but also like I think one of the important things is to have is like this provable compliance. If somebody wants to be compliant and have ability to prove that they're compliant, that should be possible. They should be able to say, okay, we're gonna, you know, uh, like one of the examples that I think about, like stable coins, for example, where they need to have the ability to freeze the funds, for example. But with ZK, we can actually have a system where they can freeze specific accounts without necessarily knowing everybody else's balances. Like you can say, okay, like as you transfer things between accounts, like this account has no, like you revoke the ability for this account to move funds, but this all can be proven on the client side, right? Like you can check on the client side whether you're part of this, some kind of denial list or something like that. And if you're not, then you're free to transfer. If you're on the list, then you may not be able to transfer. Again, this requires quite a bit of thought of how exactly this is going to work. But this is one of the things that we're delaying post mainnet. We will kind of spend time on this once we go to mainnet and once the basic things are working. I do think we will come up with good solutions there. But in the meantime, there is no regulatory issues for us as far as I can tell.
Cool. Please keep us updated. Maybe we can
Yeah,
have another episode to talk about this.
yeah,
Yeah.
definitely. I think one of the things I wanted to mention, and I didn't like, I did mention like the need for privacy is like very significant. I do think this is going to become very, very obvious in the next couple of years, or maybe 2 to 3 years. And one of the reasons for this is like the AI, right? So like right now, um, being able to track people across chains and tie addresses to real world identities is possible, but it is just very, very costly. And there's like you need to be a state level actor to be able to do it and engage those services. In 3 to 5 years, you would be able to train like AI models on blockchains, and AI will be able to correlate all activity. And so the accessibility of those tools will become much more widespread. And where to the point, like you send me some ETH, I'll take your address, I'll plug it into a tool, and the tool will say, okay, Queenie was the one who sent you this. And by the way, this is all her activity on Ethereum, on Solana, on every other chain. Here's how it correlates, and here's what she's been doing over the last 10 years on this. And I think this actually not a lot of people realize how like damaging that could be
Yeah.
once these tools become widely spread and available.
Actually, your Edge blockchain concept reminds me of Edge AI, this use case.
There is some overlap there, although I do think they're quite different. But yes, I think in many things like there's edge compute, edge AI, like in some ways you do realize that like you don't want everything happening in a centralized, even if the network itself is decentralized, you don't want necessarily the network to do all the things. You want to leave it to the people to do as much of computation. It's better scalable and you get better privacy in this.
Yeah. So, Bobbin, before we wrap up, would you like to highlight maybe some upcoming milestones? And
Yeah,
also,
so
yeah, when are you aiming to launch the mainnet?
Yeah, so I think we're on alpha testnet right now. I think we're hoping to transition to beta testnet maybe in the next, I would say 6 weeks or so. Plus minus some buffer. I think overall we're aiming to get like to this mainnet as I described, like centralized L2 by the end of the year. Now, there is like some buffer around this, but our goal is to like be technically ready to go to mainnet before the end of the year. And then obviously there's a ton of work left after the mainnet, like the whole decentralization, increasing the level of privacy and all that stuff. It still will take years, but like to get things in the hands of people where they actually can build useful applications. We're hoping to do that by the end of the year, or like maybe Q1 of next year, the latest.
That's exciting. So before you go, we have one last question for you that we ask every guest. So please name a project that you're bullish about.
I think. I mean, I'll be very kind of like true to my ZK roots, I think like I'm really bullish on various ZK VMs, and there are actually multiple projects out there. I think Risk Zero, Succinct, I think Irreducible, like there are very different flavors of ZK VMs that are being built, and I'm very bullish on ZK VMs in general. Which one will be successful in the end is like I do like the idea of like I mean, as much as I like RISC-V VMs, I do think we would like to explore like non necessarily like more ZK friendly architectures. So like there are I think Irreducible has one of the ZK VMs that they announced recently. I'm very, very curious how that will develop. I'm not so gonna say like I'm like very bullish from like it's more kind of from an intellectual standpoint. I'm very curious of how this is gonna work out, because I do think like non-RISC-V VMs are also very interesting, and see how they will come about is one of the things that I'm very, very interested in.
Mm-hmm. But they're also your potential competitors.
I mean, I think the space is big enough, to be honest. I don't necessarily like. I think, you know, I don't see Miden VM as necessarily like, if there's a better VM that we can use down the road, I don't mind switching. Like, I think Miden VM is like definitely a big part of our protocol, but the protocol is broader than that. I mean, not to like switching to a different VM is a big undertaking, but I do think like you know, Ethereum has started with EVM, and now Vitalik is talking about switching to RISC-V, so it is possible. Yeah, but I do think like being able to run ZK very efficiently in the VM, both on the client side and the server side, is like exciting. I think. And maybe this is going like one of the other things, like, and this is on the proving system side, that is I'm also very, I'm not going to say bullish, but excited about to see how it develops, is kind of like lattice-based commitment schemes and using lattice-based cryptography in proving. I think with what we have right now with hash-based systems, I think it is very good, and maybe there is like a little bit more left in terms of like improvements on the actual proving systems. I do think with hash-based systems, most of the kind of performance unlocks are probably on the hardware side, not on the software side anymore. Maybe there's like another 5x left on the software side, and by software I also mean like underlying proving systems. I do wonder if like the lattice-based systems unlock a bit more beyond that. So like I'm curious about how those will develop as well.
Yeah, we're also very excited for lattice-based cryptography. Cool. Bobbin, thank you so much for joining us today. It was great to learn about the different aspects of Miden. And for those interested to learn more, we've added some links in the show notes. Thank you, Bobbin.
Thank you for having me.
Thank you, Omar, for co-hosting.
Thank you.